Have you ever stopped to think about how a self-driving car can tell the difference between a stop sign and, say, a tree? Or how your phone magically finds every single picture of your dog? It honestly feels like magic, right? But it all comes down to solving one massive challenge. How do you teach a computer to see? Well, today, we're going to dive in and explore one of the really foundational ideas that made it all possible.
All right, so let's just kick things off with a really basic question. How does a computer learn to recognize an object like a car? I mean, it can't just look at it the way you and I do. It needs a system. It needs a language to describe what it's seeing. And that is exactly what we're going to unpack today. How to build a visual language from scratch for a computer. And the big idea here is actually borrowed from something we're all familiar with, analyzing text. A text document is really just a collection of words. So the thinking goes, what if we could treat an image the exact same way? What if we could break it down into its own set of visual words? This analogy right here is the key to understanding everything that comes next. Okay, so to make this whole thing work, the very first thing we've got to do is create a dictionary for our new visual language. We need a vocabulary, a set of all the important little patterns a computer might see when it's looking at pictures of cars. See, a computer can't just look at a whole picture and get it. It's just way too much information, too many pixels. Instead, the really smart approach is to find small, distinct, and most importantly, representative patterns within the image. These are going to be the building blocks for our entire visual dictionary. So, the question is, how does it actually find these important little patterns? Well, the system starts by scanning images for what are called interest points. And that's just a fancy way of saying it's looking for spots where something visually meaningful is happening. An interest point isn't just some random pixel. No way. It's a location that has a ton of information packed into a really small space. Think about the sharp corner of a car's window, or the edge where a tire meets the road, or maybe that unique, bumpy texture of a headlight. These are the details, the clues, that help us identify what we're looking at.
And the cool part is, a human doesn't have to go in and circle these points by hand or anything. There are these really powerful algorithms designed to do just that. Tools like the Harris Corner Detector or SIFT, they automatically scan thousands of training images and flag all of these information-rich locations for us. It's all automated. All right, so now we have this massive collection of thousands, maybe millions of these interesting points from all our training images. Now for the really clever part. How do we turn this giant, messy pile of data points into a clean, organized vocabulary of visual words? Here's how it works. It's a three-step process. First up, the algorithm goes and grabs a tiny picture, a little patch, around every single one of those interest points. It's like having thousands of tiny little snapshots of corners and textures and edges. Next, it uses a clustering algorithm to group all the similar-looking patches together. So all the patches of tire tread go into one pile, all the window corner patches go into another, and so on. And finally, the algorithm finds the most representative patch from each of those piles, kind of like the average, the center of that cluster. And that becomes our official visual code word. So a visual code word is basically just a nickname for a common pattern. Instead of dealing with thousands of slightly different images of tire tread, the computer now has one single super efficient concept it can call, say, code word number 73, which we know means tire tread. It's an incredibly efficient way to represent a whole bunch of visual information. And this is maybe the most important thing to get here. This entire dictionary building process is completely 100% automated. We just feed the machine a ton of pictures of cars and tell it, go find the patterns. The machine actually learns what a tire or a window looks like all on its own. It's a really fundamental idea in machine learning. Okay, we've built our dictionary. That's awesome. But now for the real test. How does a computer use all these visual words to actually analyze a brand new image that it has never, ever seen before? Well, when you give it a new photo, the computer first goes through and finds all the interest points, just like before. Then, for each of those points, it looks through our shiny new dictionary and finds the code word that's the closest match. By doing this, the computer is basically translating the image from a meaningless grid of pixels into a meaningful list of labels. We call this a bag of visual words. So the image might be described as having, 5 tire tread words, 10 window corner words, and so on. But wait a minute. This probably raises a big question for you, right? A bag of words is useful, but it totally loses all the spatial information. I mean, in a text document, it doesn't really matter if the word tire is at the top or the bottom of the page. But for a picture, knowing the tires at the bottom is kind of important, isn't it? Of course it is.
And check this out. This is where the next really clever part comes in. During that training phase, when the algorithm finds a tire word on the left side of a car, it also learns to store a little arrow, what we call a vector, that points from that tire right back to where the car's center.
And if it finds that exact same tire word, but this time on the right side of another car, the arrow it stores points the opposite way, but again, always pointing back toward the object's center. It's essentially building this internal map of how all the parts of an object are supposed to be arranged.
So by combining the what, that's our visual code words, with the where, these little displacement vectors, the computer gets a much richer, way more robust understanding of an object. It's not just a random jumble of words anymore. It's a structured model of what a car looks like. All right, so let's zoom all the way out. We've gone through the nitty-gritty of the process. But why does this whole bag of visual words approach matter so much in the grand scheme of computer vision? Well, there are a few huge reasons. First off, it takes these messy, high-resolution images and turns them into a simple, compact list of features, which is so much easier for a computer to work with. And second, it cleverly took these powerful ideas from text analysis and proved they could work for images too. That just opened up a ton of new possibilities, and it made this a real cornerstone technique for object recognition for many, many years. Now, it's really important to put this into today's context. These days, methods like deep learning with what are called convolutional neural networks, or CNNs, have pretty much taken over. With CNNs, the network learns the best features all by itself, automatically, without this whole explicit step-by-step pipeline we just discussed. But understanding the visual code word approach is still incredibly valuable, because it gives you the core intuition for how all computer vision systems work. They find important features, and then they interpret them. And that kind of leaves us with this one final fascinating thought. We just walked through how a machine can build its very own vocabulary to make sense of the visual world completely from scratch. It really makes you wonder, if a computer develops its own unique language to see, what does the world actually look like through its eyes?